All right. Hello, everybody. This is Alok Sinha and Burt Beckwith from Oracle Labs. We're from the RAR Cloud Native team, and today we are very excited to talk about Cloud Developer Kit, or CDK. And it's an open source platform to enable Java to perform CRUD operations on cloud resources. Let's see. So questions that are obvious are like, why do we need it? And what's it, what it is, and let's go deeper into the code, and then Burt will give you a full demo, which I think is pretty exciting. That's me. Okay, so what's the problem we were trying to solve? The problem we were trying to solve is that, and by the way, this is written from an Oracle point of view, but this is true for all clouds, that we all use resources, whether it's a VM or a load balancer or database, what have you, using Terraform, right? The Terraform is a wonderful language. There's nothing wrong with the language itself, or but it tends to become large. It's hard to debug it, and it's very easy to make an error, whether it's syntactically, architecturally. Sometimes you don't know the limits, and so we make a change, we submit it. Terraform tries to execute it, and then it runs into some kind of problems, and then we have to go do this. And every time we make a change, we have to make a change. Yeah, it takes minutes, sometimes hours, to get these Terraform scripts done right, and it's tedious to debug it. So our approach is like, hey, can we express our interest in the cloud resources in Java or other Java-like JVM languages? So the answer is yes. You will see how easy it is to then create, edit, and understand and debug and run this right from VS Code, in fact. And over time, what will happen once the CDK itself is well developed, that we will enable it so that a developer can basically do CRUD operations from VS Code itself. That's where we're headed. So what is out there? So clearly, other developers have recognized the same issue, and so Terraform has basically HashiCorp has a Terraform CDK, has support multiple languages. Amazon actually came up with the CDK. I think they may have been the first one to create it, if I'm not mistaken. It's pretty good actually, and they have a lot of documentation on it. Believe is another company/effort on that way. So there are multiple efforts on this way. So the way we wanted to do this is use Micronaut Java framework itself as a starting building block, and then build on top of that, and of course target Java developers. And essentially what we want to expose to the developer is a bunch of classes, right? If I give you a bean, now you can do something with that bean. That's the idea. And then the way you want to express your resources in what we call a spec or specification. So which basically has a bunch of required parameters. Like, if you're creating a VM, you have to say, how big do you want it to be? How much memory do you want it? What image size, what image type you want to go with that. And then there are sometimes optional parameters, and depends on which cloud vendor you're talking to. Some of them have a few, some have many optional parameters. And then, as I mentioned, some like memory is pretty well known parameter, but a particular cloud may have a very, very specific type of named parameter. And so we don't want you as a developer to have to memorize all these things and make your provisioning of cloud resources to be tied to a specific vendor language or a specific syntax. Which is the goal of the CDK. So you say it in a very loose, you say almost English-like in a specification. And once you have done that, we enable a dry run. So you give the spec, and you'll see that in a minute. As you can see in the few lines of code below, you basically create a new spec, and then you run a report. And if the resource exists already, then you get an acknowledgement like, yep, this sort of resource exists. And of course, it's going to be idempotent. If it exists, it doesn't create it again. But if it doesn't exist, then it'll create it or try to create it, and either way, you will get a report back. So that's the idea of that. What I will be doing now is sort of handing it over verbally or visually as well to Burt to do actually a demo run that he recorded, so you can get a glimpse of what is actually happening, and then we'll come back to the PowerPoint. With that, I'll give it to you, Burt.
Okay. Yeah, I thought I would share my screen and show some of the code. So are you seeing Java code in IntelliJ? I'm sharing the correct desktop.
Yes. Yes.
Okay. Okay. So CDK. So a little history. This started out as an idea of Alok's, and we've been having some students in a sort of an internship program. You know, sort of an unpaid internship. They're getting college credit, and we're hopefully going to hire some of them if they're good at the stuff. And along the way, I've been coding along with them, and so it's only been a thing for a few months, and later on we're going to ask for volunteers, because one of the things we want to do as part of this talk is to get people excited about the prospects of using this sort of thing, and get some help, because this is going to be an open source project, and so I think it's been really fun to work on, and there's a ton of work to do. Some not so fun and some really cool. So we need lots of help. So what does it do? So basically it's kind of at a very high level, kind of like a Liquorbase or Flyway, you know, database migrations, right? So you're factoring a database with a migration script to add a column, drop a constraint, to drop a table, whatever. You know, if you've used those tools before, and we want to sort of apply a similar concept to cloud resources. So be able to create them, modify them, eventually tear them down. So one of the things that Alok mentioned is idempotency is a huge part of this. So we need to know if you're trying to provision a virtual machine, but it's already out there. How do we know that? How do we know that the thing you want to do is already there? So one thing we can't do is we can't refer to it by the cloud native ID. Like in Oracle Cloud, there's an OCI ID for everything. Everything has an OCI ID. We can't use that because if something doesn't exist yet, we wouldn't know. So what we do is we have this concept called the CDK ID. And because most clouds, or every cloud that I've used, you can tag deployed resources in the cloud with various tags, whatever you want. One of the things that we do is when we build something, we tag it with a unique name, and then that's the way that we figure out, is it already out there? So if you have a VM named VM1, the CDK ID is VM1. Hopefully it'll be more creative than that. Then we're going to look and see, is there one out there tagged with VM1? Now, right now we don't support updates because this project is still in its infancy. So, but eventually what we'll do is we'll say it exists, but it's different from what we want. So let's modify it. You know, it's got say 8 gigs of memory, we want to bump it up to 16. So we make that tweak, and then that's all we have to do. Or it's not there at all, so we provision it, attach it to a subnet, and maybe put it in a load balancer, and do that work. So this is something that Alok pointed me at a while ago. It's an Oracle thing that we're not directly implementing, but it's basically a high availability web app. It's pretty standard pattern, right? So you've got a network, and you've got a database. You've got multiple web servers that are running behind a load balancer that are talking to that database, and that's highly available. You can auto scale those, or you can manually scale that. You can. It's a typical, web development nowadays. So this comes with a Terraform script, or large set of Terraform scripts. Oh, do that. So what I did was I downloaded the Terraform scripts and basically converted them to the code that the approach that we use in CDK. So one of the core features of this is a specification, or a spec. So a spec is what you want. And we model existing things that are deployed out in the cloud as components. So a lot of the work here is basically diffing what's there versus what we want, and what's that delta. So the delta is some things need to get removed, some things need to get created, and some things need to get modified. Standard sort of stuff, right? So you can see from the code that we currently have support for AWS, Google, and OCI, and we're going to be adding support for Azure, and maybe other clouds also. So there's a set of core interfaces, and it's a Micronaut application, but it isn't a web app. It's sort of an interesting use of Micronaut in kind of a small way. So basically what we use it for is bean management and singletons and dependency injection, that sort of thing. But we don't have, it's not a Micronaut app in the sense of like a microservice, right? This isn't a microservice, this is a utility. So it can run inside of a microservice, or it can run from the command line, or eventually it'll get plugged into VS Code using an extension. Because one of the things we want to do is be able to manipulate cloud resources right from inside VS Code using this framework. So we have pretty grand plans. So this is kind of an encapsulation of the whole process right here. So this this code right here. So what we do is we build up specs, and we can have one or many, and then we pass that to the central class in the whole system, the CDK class, and we pass in authentication information. So that's cloud specific. So that tells us what cloud you're on, and it has whatever you need to do to connect to that cloud, right? So like for AWS, you need those two keys, the access key and then the secret key, right? And you can set those as environment variables or from a file or whatever. With OCI, there's a similar but different approach. So basically, everything's really generic at this point. So you don't really know here whether we're using OCI or AWS or Azure. We don't really care. One of the big motivations here is to try to keep the code as cloud agnostic as possible, so that you don't have to think about how do I deploy a virtual machine to Oracle Cloud? How do I deploy a MySQL database to AWS? You just say, how do I deploy a MySQL database? So for the demo, I tried to replicate this. So creating a VCN network and a subnet and a load balancer and a MySQL database and 3 virtual machines, and then wire everything up. So what we can do is we can set up dependencies between these specs. So that determines ordering. So basically the flow, the dependency chain is that the network is first, and we wait until that's there before we do anything else. And then after that, we can create the load balancer or the MySQL, because those have the same relative position in the graph. And then after that, we can deploy the VMs. So these are sort of intentionally not ordered because they're going to be sorted by their dependency graph to build that up. So creating a spec uses this builder pattern. So it's very fluent. You just hit the dot, and if there's something that we didn't specify before, we can add in another port, 8090, 8091, whatever. So this is additive. So this is going to open up 2 ports to the firewall, so you can access both. We're going to configure the CIDR block for the subnet and the VCN. We're going to, well, I don't want to talk too much about this because that's what I'm going to talk about. I'm going to play a demo that I recorded earlier. So yeah, let me do the demo, and then we'll come back to the code if people have questions. So
Hey, Bert, I'm not hearing you. There's no voice.
That is not good. All right, I will narrate this as I'm going, I guess. But I'm going over, I'd already kind of talked about this. So we pass in the CDK ID, which is the core, super important thing. And that is a way that we can identify the object later to see if it needs to be updated if it already exists. And then we can also use that as a reference. So for example, after deploying a virtual machine, a compute instance, we want to attach that to a load balancer and also assign that to a subnet. So the way that we do that is we create a reference. So you can see that when we build the MySQL, that for example, the MySQL spec has a reference to the subnet. So because the MySQL gets created after the subnet, by the time that we're creating the MySQL instance, the subnet will be live and it'll have the tag for that CDK ID, and then I can do the lookup to get a reference to that, and then set the ID of the subnet in the API call to connect all that. So, and down below when we scroll down, when we create the virtual machines, we actually create two references. We create a reference to the subnet, so that we get the right IP address range, and we also create a reference to the load balancer. And then the logic says if there is a reference to the load balancer, attach it. So the builders are have some validation logic. So there's a core set of properties that are required, and then there's optional stuff. So, and then there's some things that can't be used together, for example. So the validation logic takes care of all of that. So you build up the builder, and create the builder and set all the values and call build, and then that'll validate that spec. And then later on, there's another validation step to validate all the specs. Later on, then we'll do the logic for go see if the instance already exists, and I made sure that nothing exists here. And it'll deploy what's missing. So we're going to end up with 5 things deployed, well, 6: VCN, subnet, load balancer, MySQL, 3 compute instances. So here I'm running the app in debug mode, setting some breakpoints. That's the core CDK class. That's the heart of the whole system. So it sets up the authentication information on a thread local so that it's available throughout the code, so you can make sure that you're authenticated and to which cloud. And we build up an application context, which you may be familiar with if you use Micronaut, or if you've used Spring. It's a similar concept. So we're programmatically building that up instead of the more automatic way that you do in a more of a like in a microservice. And that's a really cool thing, is that you can. So we don't really use Micronaut in the sense that you might have thought. Like I said earlier, this isn't a microservice, but we're using some really cool core features inside of Micronaut to get singletons and dependency injection and all that stuff. So we grab the spec processor or instance. There's a default implementation of that, and then we send that specs over to that. And there's basically these 6 steps. So we're going to validate first, and then we're going to do the full spec resolution. So that's basically merging together the explicit specs that you gave me as the user, me being CDK, and then we're going to figure out the implicit specs based on those. So depending on what we know, you also need, like, one of the things that we could do is, if you don't specify a subnet, but the API allows not setting it and it'll just pick one, then that's an implicit spec. So then we look for the deployed components to see if we need to do updates or not. And right now we don't support updates, so that's kind of a no-op. And we build a delta. So that's the creates and updates. We don't support deletes yet. We will probably in the future. And then we build commands, and commands are basically just a create command or an update command. And then we pass that to the runner, and then it finds all the individual runners, and those do the actual deployment. Okay, so here I'm just showing you that, so that's, you can see that we have a dependency injection up here of a bunch of component resolvers, and we just loop through those and ask them, is there a component out there? And if so, collect it, and otherwise there's nothing there, so we just need to do a create. So we can see that there's two breakpoints in most of these classes. One is that before the lookup, and then, so we should never hit the inside breakpoint because nothing's out there in this, currently anyway. And now we're into, okay, so now we're at deploy network. So this is the OCI network command deployer. So this is the OCI specific deployer for networks. If I had logged in on AWS, then it would be running in AWS mode. So this has got a bunch of Oracle Cloud SDK code. The Amazon AWS equivalents have the same sort of thing. So we hide all that. We still make those SDK calls. All right, so the network was just deployed, and now you can see that it's already live out there. Now the load balancer comes next. So we pull out the data from the spec, and then we set those values in the API calls and run it. So now we have a load balancer is creating. That's cool. So now it's been tagged with the CDK ID, and it's got an OCI ID that we can reference. So now I can link other stuff to that by creating a reference by its CDK ID or by its OCI ID if I had that, or its cloud ID. So one of the interesting things here is when I first ran this, it ran the MySQL, when I was first playing with this over the weekend, it would do the MySQL first and then the 3 VMs. But when I randomized the order, then because they all have sort of the same priority, then it mixed it up. It did a VM first and then a MySQL, then the MySQL, and then the 2 VMs. And at first I thought I'd broken something, but that's because that's what the dependency graph told it to do. So we probably should change I probably should change this example so that the VMs depend on the database, because obviously if we were deploying an application to the VMs, we wouldn't want to try to, they would fail at startup because the database isn't live yet. So that's one tweak, and I made things a little bit too simple, but it's totally supported. We could easily add that right now. So this is a little slow. We don't need to wait for the load balancer to finish deploying before we do the other stuff. But when I was doing the VMs, they went too fast. And what I do is, if you ask me to connect it to a load balancer, I need to go find the VNIC, the virtual network card, to get the IP address. But because of timing, the instance is available and the instance OCID is available, but the VNIC wasn't live yet. So I had to, the Oracle Cloud SDK has this concept of waiters. So you can wait until something is done, wait for the state to be available, for example. So, so when I first ran this, it ran really quickly, but then it failed. So it takes a little bit longer because we have to wait for the each VM to completely deploy, but that just takes a minute or two, so it's not terrible. And another optimization we're going to add in probably much later is parallel running. So for example, so right now everything's just sequential. But once we figure out that we have a dependency graph, right? So we have the I don't know how you want to think of it, but the network up at the top, and then load balancer next, and then the 3 VMs, for example. So those 3 VMs are independent. So we could create them in parallel. We don't have to do them in order. We don't have the logic for that yet, but eventually that'll be a feature of this whole thing, is that it will parallelize everything at the same dependency level to make the performance a lot faster. So right here is something interesting. The load balancer looks like it's failing, right? But that's because I set up a health check on the load balancer, but we don't support like deploying applications out to the VMs yet. So there's nothing running out there. There's no app there running with the health check endpoint available to call to. So the load balancer is correctly saying, alarm, alarm, alarm. We can't contact these instances. But in a real scenario, check back in a few months, or volunteer and implement this yourself. We will SCP the application up to the cloud, a jar file or whatever that is, and maybe even install Java before we do that, because that's one of the things that the Terraform stuff would do for us. So it's all in the plans. We anticipate having quite a bit of functionality of Terraform, but instead of using text files that are I find them kind of cryptic and weird to read. I'm a Java developer, Java programmer, right? So I want to write stuff in Java code, and we get compile time checks. You can check the stuff in source control with the rest of your application. A lot of benefits to having instead of a bunch of text files that sort of work, or maybe they don't, or I don't know. I just find this a lot more sensible. So we just finished. So this is what we call the run report. So it's not very well formatted, but it basically gives you a bunch of information. So it gives you all the deployed components, and it just takes the toString of those. And this is a very simplistic dump of the information to the console. But in a real world scenario, you would obviously take that report object and programmatically inspect it, and maybe generate your own special, your own reports, however you like. So yeah, so that's a demo. It's pretty cool. It got a lot cooler in the last week or so as I was prepping for this demo. Added a lot of functionality recently. So yeah, does that make sense to everybody? I know I glossed over that really quickly. We only have 30 minutes for the talk. So I could spend hours just talking about all the cool functionality in this thing. But hopefully that's interesting and holds promise for everyone. And yeah, one of the things, like I said, one of Alok's ideas for, the whole reason we're giving this talk is to get people excited about using it, but more importantly, to get people excited about helping out. Because this is, like Micronaut, something that Oracle is, sponsoring and providing for free to the world, and it's open source. So if you've contributed to open source before, that's great. If you haven't, now's a great time to help out with this. Like I said, there's a ton of work to do here. Sometimes when I work on really hard problems for a while, I just like some grunt work. There's plenty of grunt work. There's also some really sophisticated, cool problems, like the parallelization thing. We have a basic dependency graph mechanism right now, but given each row of the dependency tree, for things that all have basically the same relative, position in the graph, those can all be run at the same time. So we should parallelize this. And one thing I would love to do is, I talked earlier about like database migrations, right? So a lot of times you'll include your migration scripts as part of your web app, and you'll automatically deploy you'll run the migrations when the app starts up. I think it would be pretty cool. Of course, there's a chicken and egg problem because you're running inside of a container that how would you have created it first? But given some functionality, it'd be pretty cool to deploy an application that then builds out a whole bunch of cloud infrastructure and starts a bunch of stuff and connects to it. Maybe you could have an app that kind of just does that, or who knows? I mean, the possibilities for this are I think really, really cool. So, and of course, we got to add more support for more clouds. There's no support for Azure, really basic support for Google. We're really focusing on Oracle Cloud and AWS to start with. So, yeah, I'll stop babbling, but yeah, this has been a really, really fun project to work on.
Right. So thanks, Burt. So I posted in the chat channel our DMs. So reach out to us. If you want to join the community, it's an open source. So come join us. And we're looking for a lot of developers to do the work with us and to make it useful for your day-to-day work. Okay. Any last comments, questions? Maybe you can stop sharing. Yeah, there you go. Yep. Perfect.
I imagine everyone's tired. It's been a long day. And we lost an hour of sleep over the weekend.
Oh, that's right. Okay. And we have a question. This is amazing. Thank you, Sachin.
And I assume, I may be speaking out of turn, but I assume that we're hiring at Oracle Labs and on Micronaut team. So, contribute to open source if you want, but we have I don't know, believe me or not, but we have a great team at Oracle. Most of the Micronaut development is being done at Oracle now. Some of it's being done externally. I work with just great, brilliant, amazing people doing really, really cool stuff. And Alok is a great guy to work for. I work with Graham Roche, who created Micronaut and Grails. I'm a very lucky person, and you could be too.
Absolutely. Okay, everybody, long day. If you've been attending meetings all day, thank you for your day. Thank you for listening, and let's keep in touch. Thank you. Bye-bye.